So this is the lesson video for physical science for section 12.4. And so as always, if you want an easy way to get all my videos in one place, just subscribe to my channel. So section 12.4 is on universal forces, and we're going to talk about 4 of them. So the 4 universal forces are electromagnetic, strong nuclear, weak nuclear, and gravitational forces. So let's talk a little bit about each of them. All the universal forces act over a distance between particles of matter, which means that the particles do not need to be in contact with each other. Now, will they still act if they are in contact with each other? Yes. It's just saying they don't have to be in contact with each other. So, let's talk about electromagnetic forces first. So, electromagnetic force is associated with charged particles. So, after you take physical science, if you move on to chemistry, that is where we base a lot of our chemical knowledge, is from those charged particles. Actually, we'll also discuss it more in the second semester of this class too, the second part of this class. So electric force and magnetic force are the only force that can both attract and repel. So most of the forces that we talk about in this section, they're always going to be an attractive force. But for electromagnetic, they can attract and repel. So think about magnets. If you do a north pole and a south pole, opposites will attract. But if you do 2 north poles, they repel one another. Okay, it's not like with gravity. Gravity, for example, always attracts. It's not like if I turn myself upside down, all of a sudden I repel and go up into the sky. Okay, no matter which direction I'm in, I'm still going to attract to the earth. Electric forces act between charged objects or particles such as electrons and protons. That's why I brought up chemistry on the previous slide, because that's a big topic, obviously. Objects with opposite charges attract, so just like I said, think about the magnets. So an electron and a proton, negative and positive, would attract, while objects with like charges repel. So 2 positives or 2 protons would repel, 2 negatives would repel. So just remember, opposites attract. That's an easy way to remember that. Magnetic forces act on certain metals, on the poles of magnets, and on moving charges. And so as we just discussed in the previous example, 2 of the same poles, 2 south poles will repel, 2 north poles will repel, but a north and a south, opposite poles, will attract one another. So let's move on to nuclear forces. So we did electromagnetic, now let's do nuclear. So 2 forces, the strong nuclear and the weak nuclear force, act within the nucleus to hold it together. Because the thing is, the nucleus, which we'll talk more about this in the chemistry portion of physical science, the nucleus is composed of protons, which are all positive, and neutrons, which are neutral. So should 2 protons want to be near each other? No, they should repel because they're both positive. But yet the nucleus holds together somehow. So that means there must be some force holding those positives near each other, because normally 2 positives would want to repel. And so those forces are the strong nuclear force and the weak nuclear force. The strong nuclear force is a powerful force of attraction that acts only on the neutrons and protons in the nucleus, holding them together. The strong nuclear force acts over very small distances. You have to think about how tiny a nucleus is. And then when we get into radioactivity later in the year, we'll learn that when the nucleus starts getting too big, that's when it starts breaking down and radioactive decay starts occurring, because the nucleus has just gotten too large for that strong nuclear force to hold it together. The weak nuclear force is an attractive force that acts over a shorter range than the strong nuclear force. Okay, so strong nuclear force can act over a larger distance than weak nuclear force. However, neither of them act over a very large distance at all. Because remember, we're just talking about a nucleus. That is very, very, very tiny. So, we talked about electromagnetic, we talked about strong and weak nuclear, so let's hit gravitational forces. So gravitational force is an attractive force that acts between any 2 masses. So we feel gravity from the Earth because the Earth is so large. It has such a high mass, it literally pulls us towards it. That's why if we jump up, we come back down. But technically, we all feel gravity with each other, but we're not constantly running into each other because we're attracted to each other. It's because our masses are much smaller, so we don't feel the effects of the gravity. So Newton's law of universal gravitation states that every object in the universe attracts every other object. But like I said, unless you get a mass large enough, like a planet or a star or something like that, you're not going to be able to feel those effects of the gravity. So the the gravitational force between two objects is proportional to their masses. So that's what I'm talking about with the planets. The larger the mass, the larger the gravitational pull. And decreases as the distance between them increases. So that's why if you can get far enough away from Earth, eventually it doesn't keep pulling you back. So if you get in a rocket and you get far away enough, that distance increases enough, it won't pull you back. You have to actually propel yourself back by flying with your rocket. Gravity is the weakest universal force compared to the other ones we talked about, but it's the most effective over long distances. Like if you think about magnets for electromagnetic, you know, if I hold them out like this, I'm not going to feel the push or pull of the magnet. Same thing with that nuclear forces, the strong and weak. We said it only acts over that tiny distance. Whereas think about gravity. I can get in an airplane and fly so many feet up in the air, and I'm still going to jump out and get pulled back down by gravity. So it's the best over long distances, but overall it's the weakest. So the centripetal force is a center-directed force that continuously changes the direction of an object to make it move in a circle. So like think about if you had something attached to a string and you sit there and spin, 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 spin. It's constantly changing direction. Now, real quick, that means it's accelerating, even if you don't speed it up. Remember, acceleration is a change in speed or velocity or direction or both. And so in the centripetal motion is constant acceleration because you're constantly changing direction. This force causes the moon to orbit the Earth. So even if the moon goes around the Earth in the same speed every 24 hours, it doesn't matter. It's still accelerating because it's constantly changing direction because of that circular movement. The gravitational pull from the moon produces two bulges in the Earth's ocean. These bulges produce the high and low tides each day. So as the moon is traveling around the Earth's oceans, because water is, you know, it's a fluid, it's movable, it kind of bulges out towards the moon because it's attracted to the moon. Now the land, that's a solid, it's not really going to start bulging. But the oceans bulge. You can see that's what this blue outline is. It's obviously not this much of a difference, but you know, they're trying to exaggerate it here. That's what causes, so then we have high tide at these bulging areas and low tide when it is not bulging. Alright, so the moon is actually what causes the tide changes throughout the day. And again, that's because of the gravitational pull. The moon is also attracted to Earth, and the Earth is attracted to the moon also. So, let's hit this section assessment. So which universal force can repel as well as attract? Well, that is the electromagnetic force. The electromagnetic force. Because remember, opposites attract, like charges or like sides of a magnet repel. Which universal force acts to hold the nucleus together? It would be the strong and weak nuclear force. The strong and weak nuclear force. So number 3, it says, state in your own words what is meant by Newton's law of universal gravitation. Well, Newton's law of universal gravitation, again, you can state it in your own words. In my own words, I would just say every object is attracted to every other object. Alright, there's not really much way you can restate his law. It was already just a good law to begin with. Okay, but like I said, you can use whatever you want for your own words, but I would just say every object attracts every other object in the universe. Alright, so hopefully you have a good understanding now of the forces, the 4 forces: electromagnetic, strong and weak nuclear force, strong and weak, and then gravitational force.